Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chiltern, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chiltern to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chiltern at 9 o'clock. He drives from Chiltern to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time. And we're covering up the time, because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through two parallel lines. which are our two north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the two angles are alternate, they're Z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table. And we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40. And we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80. And the frequency is how high it is, which is 10. The next midpoint is here. So that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160, so that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers. Just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares. And we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450. On the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them. So I cross them both out and put 2 in the middle. We can see they both have a 3 in them. So cross those 3's out and put 3 in the middle. And then 450 has a 3, a 5 and a 5. And 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle. And so the highest common factor will be 6. So angles on a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together. And so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. There are two rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now, this red line does not go through the origin, so A and B cannot be in direct proportion. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have A, we've got our B, and we're going to call X the C. So it'd be A squared plus B squared equals C squared, but this time A is 39. B we are given as 47.148, we've just worked that out, and we're looking for C. In fact, we can call it X now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to X squared. And we just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to X. It says it wants its two decimal places, so that will be 61.19. So we're given 21:4 is the ratio, and we're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay? And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants its two decimal places, so it's going to be 1 to 0.19. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. A frequency polygon is like a line graph. In fact, it's a type of line graph. But it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80. And then 18 at 80 to 160. And 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph. And it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So it seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160, and it's 18 high, so it would be up here. And then the final one is at 200, and it will be 6 high, so 200 is halfway, and we're looking at 6 high, so it will be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up. Perfectly straight lines, and there we are. So we're just going to copy this out first of all. So we've got x equals y over 15. Now we're asked to make y the subject, which means we want y on its own. What's stopping y from being on its own? Well, it's divided by 15. That's what over means. It means divide. So how do we get rid of that divide by 15? Well, we do the inverse or the opposite, which is times 15. So we go times both sides by 15. X times 15 is 15x. And it will get rid of this fraction here and just leave y. So y is 15x. When working out if two triangles are congruent, which means they're the same, you can either have RHS, which is a right angle hypotenuse side. You can have 3 sides that are the same. You can have 2 angles then a side, or an angle then a side then an angle. Or you can have a side, then an angle, then a side. In this question, we have a right angle. We only have 2 sides, so we can cross this one out. And if you look, that the 2 sides are next to each other, then the angle. So it's ASS or SSA. So these don't really fit. But the angle is a right angle. So we've got a right angle on both of them. We have the hypotenuse. And we have a different side that are all equal. So the proof here is RHS. So let's just write out this sequence. So first thing we're going to do is work out what the sequence is going up in. And we can see here that we're adding 15 each time in our sequence. And whatever the sequence is going up in is what goes before n, so it's going to be 15n. Now 15n would give us the 15 times table, and this isn't the 15 times table. So to work out what the offset is, we go and find our 0th term. So instead of adding 15, when we go backwards, we're going to take away 15. And so that would be 10. And so our answer is going to be 15n, and we're going to add that 10 on. So the distance initially travelled is going to be 14 kilometers for this stint here. And then we have a bit of a rest. A horizontal and distance time graph is essentially stopped. But then here we start up again to go home. And so that's another 14 kilometers travelled. So in total, there has been 28 kilometers travelled. When you have a fraction, it's just a fancy way of showing a divide. So this is x to the power of 11 divided by x to the power of 3. And indices rules say that when you divide two powers with the same base, you subtract the powers. So it becomes 11 take away 3. 11 take away 3 is 8. So that's x to the power of 8. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. and then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. To find the gradient, we need to first of all find 2 coordinates we know. So I'm going to pick this one and this one. And to find the gradient, we're just going to draw a right angled triangle between them. And the gradient is the change in y over the change in x. But here you can see that we've gone down 3. So it's a -3, it's gone down 3. And we've gone 1 to the right. So that's going to be -3 over 1, or just -3. So the gradient, a different definition of it, is how far up we go when we go 1 to the right. So here we've gone 3 down, so it's going to be -3. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I could pick the 2x plus 3y equals 41 and just substitute the value of x in. So 2 times, instead of x, it's times 10 plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93, so we know we've got it right. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side, so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now, the two triangles are similar because the sides here we assume are, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A, and so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20, and then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different, which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions, or solution, because they're both linear, will just be where the two graphs cross. So this here will be our solution. So x is 2 and y is -4. So we've got a right angle triangle here, and it involves two lengths and an angle. So we know we're going to be using trigonometry for this. And first step of trigonometry is labelling the sides. So the one opposite the right angle is the hypotenuse. The one opposite the marked angle is the opposite. And the one between the right angle and the marked angle is the adjacent. Now notice there's not a number or a letter next to the adjacent, so we can cross that out straight away. Next thing we're going to do is draw our triangles for SOHCAHTOA. So I'm going to have SOHCAHTOA. And we've crossed out the A, so we're going to cross out the Ka and the Toa because they both involve an A. That leaves SO. And SO is short for sine x, or sine the angle, equals the opposite over the hypotenuse. So the angle is 83, so it's going to be sine 83 equals the opposite, which we've labelled as x, over 7.9. Then we can put our solving lines in, and all we need to do here is times both sides by 7.9. And be careful when you do sine 83 times 79. Most calculators open a set of brackets when you type in sine, cos, or tan, so make sure you close them after you type in times 7.9. And when you do that, you get 7.841 blah 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 equals x. And so rounding that to 2 decimal places is 7.84. So there are two outcomes that it will rain once in the next 2 days, and that will be rain and not rain, and not rain and rain. So to work out the probability, it will rain on Monday and then not rain on Tuesday. What you're going to do is just multiply 6 over 20 by the 2 over 7. So 6 over 20 times 2 over 7. And that will give us 12 over 140. And to work out the probability, it will not rain on Monday and rain on the Tuesday. We're just going to multiply the 14 over 20 by the 5 over 7. And so that would be 14 over 20 times 5 over 7. And that will give us, 70 over 140. Now we're looking for the probability it will rain and not rain, or not rain and rain. The word or in probability means add, so we're going to get that 12 over 140 and add it to the 70 over 140, and that will give us 82 over 140, and then we can cancel that down to 41 over 70. First thing we need to do is find out what 10% of the 109 is. So we're just going to multiply by 0.1, and that gives us 10.9. So what we're going to do is we're going to add and subtract this from 109. So we're going to do 109 take away 10.9, which gives us 98.1. And then we're going to do 109 plus 10.9, which will give us 119.9. So our error interval is between 98.1, and it says to use t, and 119.9. This question, we're adding fractions. Okay, there's a bit of algebra, but the process is exactly the same as when we've always added fractions. We need to find out what the lowest common multiple of 4 and 7 is. Well, actually, the lowest common multiple is 28, which is 4 times 7. So what we're going to do is multiply the left-hand fraction by 7. So we're going to times the k by 7, which will give us 7k. And we're going to times the 4 by 7, which will give us 28. And we're going to times the right-hand fraction by 4, which will give us 4k at the top, and it will also give us 28 as the denominator. Now, when the denominators are the same, we just add the numerators, and 4k plus 7k, or 7k plus 4k, will be 11k, and the denominator will be 28. This question doesn't involve using a circle theorem, but it is something you'll need to spot. And if we look at this triangle, something you need to notice is that these two lengths here are both radii, therefore they are equal. Therefore we can work out angle OAB because it's going to equal 70 degrees. And the reason it will equal 70 degrees, which you need to write down to make sure you get the mark, is that it is an isosceles triangle. And in an isosceles triangle, the lengths that are between the equal lengths and the non-equal length are always equal themselves. And then to work out what x is, we just simply do 180, take away the two lots of 70, which will equal 40 degrees. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. I get it just perfect, there we are. Okay, next thing, we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. If we draw out this rectangle, we can go through the distances one by one and find out what they have to be to maximize the perimeter of the rectangle. Now, perimeter is obviously the distance around the rectangle. So we're going to start off with the 24 centimeters. So the maximum that could be, well, the biggest it could be before it rounds to 25 is 24.5. And so these are both going to be 24.5. 98 centimeters, well, the maximum that could be is 98.5. And so to find the perimeter, all we're going to do is add all these together. So 98.5 plus 24.5 plus 98.5 plus 24.5. And that gives us the answer of 246 centimetres. The parts of a box plot are that the lowest value is on this side here. The lower quartile is this bit here. The median is this bit here. Upper quartile, and then the highest value. So the median is this part here. And we can see that is at 23. So the median is at 23. We're asked to solve this quadratic, and we're told that we're going to put the answers to two decimal places. So we're going to be using the quadratic formula. For the quadratic formula, we need to work out what A, B, and C are. A is the coefficient of the x squared. Now, it doesn't look like it has a number before it, but it does. There is a 1 there. So A is 1. B is the coefficient of the x, which is 5. And C is the number left on its own at the end, which would be minus 20. So we're going to write out the quadratic formula. And we're going to substitute in the value. So it's minus b, and I always put the values I substitute in brackets on the calculator, because if they're negative, we can get into problems. B squared minus 4 times a times c over 2a. And if you type that into the calculator with a plus there, so change that for a plus, you're going to get the answer of 2.623 blah blah blah. If you go back on the calculator, use the cursor keys to change that to a minus, you get the answer of minus 7.623 blah blah blah. Rounded to two decimal places, that's going to be 2.62 and minus 7.62. We're going to start by creating a table of frequencies from this histogram. And so we are going to need our times, first of all, then our frequencies, and then we can add a midpoint and an fx column as well, which we'll need for later. So our times, then our frequencies, then our midpoints, then we'll do the fx later on. Right, so the first group is 0 to 10. And to find the frequency, I might as well just show this. So the frequency density is proportional to the frequency over class width. The class width here is 10, and the frequency density is 1.2. So 10 times 1.2 will be 12. And then the next group is up to 30. So we're doing 20 times 3.2. which will be 64, and then the final one will be 30 to 50. So again, we're doing 20 times 0.8, which will be 16. Okay, so we've got our table from the histogram, and we're asked to find the mean, so hence us doing the midpoint, etc. So the midpoint is 5, 20, and 40, and then the fx, we just times these together, and that would be 60, 1280, and 640. Now, something I said earlier is that the frequency density is proportional to the frequency divided by class width. It does tell us there are 92 people, and if you do the sum of the frequencies, you do get 92. So we know that it's a one-to-one relationship. Okay, so let's do the sum of the fx by adding up these numbers here, and you get 1980. So to find the mean, we do the sum of fx over the frequency, sum of the frequencies, and that will give us 21.521 blah blah blah, and two decimal places, which is what the question asks for, it's 21.52. So we have the original y equals fx shown in the graph. And it says it has a minimum at 1, -1, so it's this one is the black line here, And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.